Hello students, in this video we'll continue with chapter 11 Work and Energy. In the previous videos of this chapter you have seen the definition of work, you have understood what is work, you can define work, you can define its SI and CGS units, and you know there are three types of work: positive work, negative work, zero work. You can explain them by giving various examples. So work part of the chapter we have already done, and now today we are going to start with energy part. Now energy is a very common word which we use in day-to-day life. When you are tired, you often say, I don't have energy to do work. Or we can say, in other words, when you have energy, then you can do work. Or if a body is able to do work, it has energy. Now, what is energy then? We use this word in day-to-day life, but we don't give its SI CGS units. We don't know the precise meaning of energy. We just know it is something which is required by the body to do work. So in today's lecture, let us see what is the proper definition of energy. Let us see what are the units. Since energy is not a quality, it is a quantity, physical quantity, it is measurable, it has units. Okay, so energy as written on the board can be defined as the capacity of a body to do work. You will also find its definition in some books. It is written as ability of a body to do work, but I find this is better. It is a capacity of a body to do work. Now energy, it means if a body has energy, it can do work, or if any body can do work, it possesses energy. So energy and work are quite equivalent in the sense, energy just like work is a scalar quantity. Energy has the same units as that of work. Its SI unit is joule and CGS unit is erg. In other words, we can say a body having energy of 100 joules can do 100 joules of work. Okay, you can also define the SI unit. Suppose if I say you define the SI unit of energy, you can say 1 joule is the energy possessed by a body to do 1 joule of work. So very simple definition you can write for the SI unit of energy, for the definition of SI unit of energy. Now energy exists in different forms: solar energy, chemical energy, heat, sound, light, tidal, nuclear, wind, electrical, magnetic. These are some of the forms of energy that we see around us. We know that sun is a basic source of energy from which many sources of energy which are available on earth are derived. Okay, so when we talk about chemical energy, we know diesel, petrol, even plants that we consume, they all come under this category, chemical. They are sources of chemical energy. Now we are able to do work. We have muscular energy. From where do we get this energy? From the food that we eat. So we get chemical energy from the food that we eat, and so our muscles get energy, and when we use that energy, we can say we convert the chemical energy into muscular energy, and that is used to do certain work. Okay, and you must have studied about sound and light also. When we write their definitions, we start like sound is a form of energy which causes a sensation of hearing in us. Light is a form of energy which causes a sensation of vision in us. Heat, we say heat is a form of energy. Tidal, we know there are tides which come in sea or ocean every day, and tides means actually waves only, but there is certain difference between waves and tides that I think so we have done in the previous chapter. Now tides, so tides are actually water moving. So water, when it is moving, okay, it has energy. You know that moving water can carry many things along with it. And initially in ancient times, actually transportation through water was done. So that water was actually moving water. Okay. Now nuclear energy, We know that nowadays for electricity, nuclear energy plants are also there. Wind energy, we know moving air is called as wind and moving air has energy. So there is wind energy. Electrical energy, we use it at home. It is a most convenient form of energy which we commonly use at home. We know that it is convenient because by using electrical energy, by using the switches, we can switch on the fan, switch on the lights and put them off according to our will when not required or required. Magnetic energy, we know that magnets can attract the magnetic substances. So because of the energy only they are able to attract. So there exist many other sources of energy also. Now, without this energy is required, obviously this energy is used to do certain work. We know that chemical energy when we eat, okay, when we have food, we use chemical energy to do work. So our muscles do work and then we are able to do a lot of work. Similarly, here different forms of energies will be seeing that they are used to do various types of work. Now in this chapter, we are going to basically study mechanical energy, which is a sum of kinetic energy and potential energy. Let us see in depth what is kinetic energy and potential energy. Then we can say the sum of kinetic energy and potential energy is called as mechanical energy. Now kinetic energy is related with motion. You know that anything which is moving has kinetic energy. For example, a moving car can do lot of work. You know, a moving ball can do lot of work. It has energy. It can harm you. Similarly, a raised hammer, if you raise a hammer above the ground, it can do lot of work. It can drive a nail into the piece of wood. So that is gravitational potential energy. We say the hammer, when it is raised above the ground, it has gravitational potential energy. Or anything lying at height above the ground is said to have gravitational potential energy. Actually, potential energy is of two types: gravitational potential energy and elastic potential energy. We'll see this kinetic energy and potential energy with more examples and the proper definitions in the next video. I'm just giving you the examples of bodies having kinetic energy and potential energy. Now when you talk about a rubber ball, when you compress it from both the sides, it changes its shape, and when then you stop applying that force, it regains its original shape again. So how does it do that? Because when we actually compress it, we are applying forces from both the sides on the ball, and that applied forces change the shape of the ball. When we remove the applied forces from the ball, then that work done which we have done on the ball to change its shape by applying force is actually stored in the ball as its elastic potential energy. And when we remove the applied forces, it uses that energy to regain its original shape and size. Okay, so we'll see this mechanical energy in depth in our next video. But right now in this video, at least you should know that energy is the capacity of a body to do work. It is a scalar quantity having SI unit joule, CGS unit erg, and any body which has energy can do work. Without energy, a body cannot do work. Okay, so I hope this definition is clear to you. So we'll continue with this topic in our next video.